Okay, we've made it to the end of week 2. We're ready for this last homework assignment. It's all about one-sided limits and the squeeze theorem. And you guys, I'm going to take just a second and explain my old school projector. I have an iPad. I have lots of technology, but there's something comfortable to me about paper and being able to actually work out problems, and I just love it. So hopefully it's okay with you and you're still getting everything that you need out of these videos. But I love it, and so I'm just using my little projector because it's the way that I like to teach. So we're going to talk about, let me remind you back from homework number 2, I showed you this picture. And we're basically just going one step up from this. So in homework 2, all of these were basically continuous, right? And so we were doing just the limit, where is it approaching, but it kind of went to the same place. So now that we're in homework number 4, you'll notice that coming this way, it hits a different place than coming this way, which is why they've separated it out and asked different questions. And so they'll do the same thing in a table and in a graph, but the answers are all the same. So this is the limit as I'm approaching 1 from the left. So when I'm coming in from the left, I'm approaching and approaching and approaching and approaching -1. But as I'm approaching 1 from the right, I'm approaching and approaching and approaching and approaching 2. And then since these are different, the final limit, they're not approaching the same place. So that would be does not exist. And again, in a lot of places you'd put DNE, does not exist, but Newton wants you to put this. So the limit does not exist because these are not the same. If these had been the same, like it was on this one, the limit coming from the left would have been 3, and the limit coming from the right would have been 3. So the final limit would have been 3. So on a problem like this, it would have been same, same, same. And so you'll kind of get a little bit of everything. And sometimes it'll be in a table instead of in a graph, but just look at the way that table's running and see where it's approaching, and look at the way the table's running and see what it's approaching, and it's exactly the same thing. And so no matter how they give that to you, those should be pretty quick. Again, not really math to do, it's just more visual. Okay, and then they've got the beginning of the squeeze theorem. So they say, I've got this function g of x that's smaller than this guy, but bigger than this guy, but only if you're in this range. And they want us to find this limit. Well, the first thing I usually check is, am I in that range? And the answer is yes, I am. And so this should just work by direct substitution. I should just be able to plug this in and get the same thing, but I'm going to go ahead and check both of them just to make sure. So I'm going to plug -4 in here and see what I get. And I'm going to plug -4 in here and see what I get. And as long as I get the same thing, then that's going to be my answer. So let's see about that. So up here, if I plug in a -4, that would be -4, which is 16, but then there's a negative out front. So that would be -16. A -8 times a -4 would be a +32, and then a -21. Then same thing here, a -4 squared is 16. A +8 times a -4 is a -32, and +11. So let's see what I get here. -16 plus 32 is 16, and 16 minus 21 is -5. So this side's -5. 16 minus 32 is -16, plus 11 is -5. I got the same thing on both of them, so I have a limit. Okay, so as long as this is between those, I should just be able to substitute it in. If for some reason these did not come out the same, then you wouldn't be able to give that limit. So that one is not too bad. Okay, and then we're going to do the exact same thing, only graphically. So these are the same, but this one is just in graph form. And so what they're going to do is they're going to give you this function f of x, and they're just going to give it to you. It's going to be written right here, and you're just going to type it in this little box. So whatever it is for f of x, you're going to type it in that little box, and then on the graph, it's just going to magically graph it for you. It's going to be so pretty. Okay, and then they're going to give you the function g of x up here, and you're just going to type it in the box, whatever it is. You're going to type the function in the box, and it's just going to graph it for you over here. Okay, and then already on there, there's going to be another function, and usually it's a crazy one that goes like up and down and up and down and up and down and up and down and up and down. Like it is wild. Like there's lines all over the thing, and you have no idea what's going on. Okay, but your job is simple. You want to see if this function is smaller than this function is smaller than this function. And the way that it should work is that this one is like the biggest, and then I might be saying this backwards actually, but it should go in whatever order the function is, that the biggest one is up high and the smallest one is down low. And here's the catch. They all three have to meet in one point. So notice that this one and this one and this crazy one that's going up and down and up and down, they all meet at this one point. So on this one, for the squeeze theorem, you would say yes, that the squeeze theorem does apply, and on this one, the limit would equal 0. Okay, but there was one that I saw where the first graph went kind of like this, and then the second graph went kind of like this, and then that crazy one was still kind of going up and down and up and down, and it hit this middle point, and then up and down and up and down. Well, I want you to remember what I said. One of them has to always be the highest, and one of them has to always be the lowest, and they have to all meet at one point. Well, here, this one's high, but then it's low, and this one's high, but then it's low. So on this one, I would say, no, the squeeze theorem doesn't apply because f of x isn't always smaller than g of x or whatever. And then sometimes there's like a gap and they don't meet up. And so then the limit just doesn't exist. So the pictures are kind of cool, but pay attention to the colors and just see if the one is always the highest and one is always the lowest. It's really just looking at it though. Just look at the picture. This is the way you want the picture to look if the squeeze theorem is working the way it's supposed to and if the limit exists. Okay, so this is a good picture right here. That's looking the way that you want it to look. So again, not a lot of computation on this one. The most you have to do is maybe plug in some numbers, but a lot of it's just looking at graphs. And so homework number 4 should go pretty quickly, and it's a lot of just visual stuff about limits. Good luck.